Okay, so if I were going to write anything in my notes, I would write amp equals 7, period equals pi, phase shift equals left pi over, oop, that's not left. Whoops. Left pi over 8 and up 3. And then your goal is to write a function, a sine function that fits that criteria. So what I want to do is I want to write y equals, leave some space, sine of, put an x in there, close parentheses, and you need to fill in all of that. So I'm going to give you a second to talk, and then we will discuss. Tomorrow. Oh, no, wait, what's that? Day what? Oh, day 1 is, yeah. Oh. No, it was just continuation of the notes. Okay, Andrew, can you tell me something? Like something that goes on there? Plus 3 at the end, and why do you say that? Because of the up 3? Okay, I agree. Alyssa, can you tell me something else? 7 in front of sine, and that's because of the amplitude? I agree. Hey guys, could I put 3 plus out front? Well, sometimes it's going to be in that position, so you just got to remember that if it's, as long as it's addition or subtraction and not multiplication, then it's a vertical shift. Okay. Rayon, how do I figure out what goes in front of x? Ah. Okay. I'm going to do it that way in just a second. Okay? But first I'm going to do it as if we don't separate the transformations. Either way, I still need to figure out, guys, what's the formula for period? So write down 2 pi over b and set it equal to the period. So if 2 pi over b equals pi, then the question is, what is b? True? So how do I solve that equation? If you multiply by b, then what are you going to do? Divide by pi. So what do you get? B equals so 2. Yeah? So that just becomes a 2 right there. Now, what's the formula for phase shift? So I could do negative c over b. What is b? 2. I could say negative c over b equals what? So remember that the formula for phase shift actually includes the direction, so it would be negative pi over 8. Are y'all with me on that? This is not the method I'm going to use in the future. Marion picked out the one that we were going to use, but we'll do that in a second. How do I solve for c? 2 or negative 2? Yeah, you could just let the negatives simplify each other out, but you are going to multiply by a negative 2, and when you multiply by a negative 2, what happens? What are you left with? Pi over 4, so we get plus pi over 4. And that is my answer. Now that is one way to solve it. Here's another way, and this is probably an easier way for most people, and especially considering what I've taught you as far as transformations go. Y equals sine of open parentheses x close close, and then we still have the plus 3. We still have the 7. We still figure out that this is 2. But what does this allow me to do, guys? Yeah, it separates the transformations. So the fact that I'm going left pi over 8 means what can I put inside the set of parentheses? Well, So remember, this is literally just the transformation by itself with the 2 already factored out. So this is plus pi over 8. So this is a direct transfer, a direct substitution inside. Do you guys remember doing that, where if you factor out this, then you have the left or the right there? Yeah? No? I don't know? Okay. Why is it plus? For fun is an option, but why is it plus? Because the opposite, because they're going left. True. That's not my final answer, though. What would I do to get my final answer? Yeah, you'd actually, the 2 is already divided out, so what you have to do is distribute it back. So it'd be 2x, and then 2 times pi over 8 is pi over 4. And there would be my final answer. Okay? So now what I want you to do is I want you to use that idea, and I want you to work this problem. So you and your neighbor talk it out. I want a cosine function with these transformations. Nope. Hey guys, did y'all notice, I mean, someone already noticed it, but did y'all notice that this is a little bit different than what we usually deal with? There's no pi, right? Well guys, think about this. If I were like modeling, say, the temperature throughout the day, and I was modeling it with a wave, the x-axis would be in terms of hours, not radians, right? You don't have to have a period that's in terms of radians. It's whatever your period is. In fact, a lot of times on the ACT, it won't be in terms of radians. It'll be something else. But anyway, so same formula, or same setup, y equals. I am going to do it with the transformation separated out. So I'm going to say, well, I don't have room horizontally. So y equals cosine okay. Kenneth, tell me something. 5 goes in the front? I agree. Jordan, Joseph, I need another one. Tell me something else. Down 7 means minus 7 at the end. I agree. Okay. Will, give me another one. Good. So you said b is pi over 3, so 2 pi over b has to equal 6. So then how do I solve for b? Multiply by b and, so switch the 2. So 2 pi divided by 6 equals b, which is pi over 3. So you're right, that would be pi over 3. Now, hey guys, this right here, can we kind of use that to make a formula for ourselves? 2 pi divided by the period equals b. If you write that down, 2 pi divided by the period equals b, then you can use that in the future. And maybe just jump straight to what b is. Okay? Tony, what do you think? What else do I know? Okay, so you just know that. The fact that I'm going right 15 halves means what could I put in here? Exactly. Minus 15 halves. Now, you're saying it's 5 pi over 2. Guys, where's she getting 5 pi over 2 from? When you distribute that, that would be cosine, obviously with the 5, I'll get there in a second, pi over 3x minus pi over 3 times 15 pi over 2. Pi over 3 times 15, not 15 over pi over 2, 15 over 2. 15 divided by 3 is 5, so 5 pi over 2. Cool? Okay, what are we missing? Yep, we do need a negative. So, took care of, oops, that already. And then reflected over the x-axis puts a negative in front of the 5. Okay. On your homework today, we're going to talk about graphing these functions. We're only going to get to tangent today. So your homework is going to have 6 graphs and then 5 problems like this, okay? Those will be in the back. Those will be the ones that you can go ahead and do as long as I make sure that you understand one or two little things, and then we'll be good, okay? So you should have your notes page. Yeah? Jordan, can you hand me one? Okay, thank you. So, I'm going to attach your notes page, guys. For this first graph, what I want you to do is I want you to write down y equals tangent, or tan x. And go ahead and get your unit circle out. Sorry, I gotta find the one I've been using at my desk so I can reference it, but if I can't find it, that's okay. Doing it? Oh, whatever. Okay, whatever, here we go. Oh, I forgot that I literally have one printed right there. I know, ridiculous. Okay, so if you guys don't, just as a reminder, what is tangent in terms of sine and cosine? So it is sine of an angle divided by cosine of the angle, and in terms of these coordinate points, it's y over x, true? Okay. So we're going to kind of talk this out as far as plotting goes, and then we'll figure it out. Okay. Can you guys tell me, let's just start at 0. What is tangent of 0? Now, tangent is y over x, so that will focus. Okay. So if tangent is 0 over 1, then tangent at 0 is 0, true? So let's go to this right here and plot the point 0, 0. Okay. Can y'all tell me what tangent of pi over 6 is? So 1 divided by the square root of 3. Would you agree that square root of 3 is greater than 1? So 1 divided by the square root of 3 is less than 1? Okay, so it's some decimal less than 1. I don't know what it is, so we're going to keep on going. What's tangent of pi over 4? 1. Tangent of pi over 4 is 1. That's an easy point to plot, so I'm going to go ahead and let that be pi over 4, and that be 1. So pi over 4 is 1. Okay. Can you tell me what tangent of pi over 3 is? Square root of 3 over 1 is square root of 3. Is that less than 1 or greater than 1? Okay, so I went from 0 to, between 0 and 1 to 1 to greater than 1. What's it look like it's doing? Increasing? Okay, so let's go to pi over 2. Now, if I made this pi over 4, then the next tick mark must be what? Pi over 2. So, at pi over 2, what is tangent? It's undefined, yeah? So let me talk about that for a second. You don't need to, you can just watch for a second, okay? So here is sine, yeah? With this being 2 pi, this being pi, and this being pi over 2, agreed? And then here's cosine. Cosine starts here, comes down, and then it has a minimum there, and then it keeps on going, and there we go. Yeah? Okay, so at pi over 2, when tangent is sine over cosine, can you tell me what sine is approaching as you approach pi over 2? It's getting closer and closer to 1, right? It's getting closer and closer. It's approaching 1. Can you tell me what cosine is approaching? Cosine is approaching 0, right? Now 1 divided by 0 is undefined, but let's talk about the numbers infinitesimally close to that, right? So right here, this is approximately 1, and I'm just going to go ahead and use that instead of 0.9999 because it's easier to think about. So if I said approximately. I'm going to go ahead and let the numerator be 1 as I get really close to pi over 2. But as I get really close to pi over 2, what is cosine getting closer and closer to? Give me a number really close to 0. I'm going to say, I'm not even going to go that close. I'm going to say 0.1. 0.1 is not that close to 0 when you're talking about infinities, right? But what is 1 divided by, what is 0.1 in terms of fractions? 1/10. If I divide 1 by 1/10, then what am I really multiplying by? That's 10. So guys, when I am only 0.1 away from pi over 2, my y value is at 10. Yeah? So it kept increasing, right? What if I got even closer? What if it was 0.01? What would that be? Oops, sorry. 0.01, that would be 100. What if it was 0.001? So what is this number getting closer and closer to? Infinity. As you approach an x value, if you go closer and closer to infinity, what do you have? A vertical asymptote. So we are approaching the vertical asymptote. So we've got something like this. Okay? Now let's go left. When we go left, we're going to go backwards, okay? So let's go to negative pi over 4. At negative pi over 4, which is 7 pi over 4, what's tangent? Negative 1. So tangent at negative pi over 4 is negative 1. And then what is tangent at negative pi over 2? It's undefined again, which means we have another what? Vertical asymptote. Good. How do I know that it's approaching negative infinity down here? Because when you look at this, wow, my sine wave went really low. Right here, when you have sine over cosine, the sine is approaching negative 1, so it's like negative 1 over, but this is still approaching 0 from the positive side, so it's still a positive 0.001, right? So it would be a negative 1,000, negative 10,000, negative million, yeah? Okay, so we have this. Okay, looks similar to a cubic, but not quite. All right, tell me, what comes after pi over 2 if we're going by fourths? If we're going by fourths, pi over 4, pi over 2, 3 pi over 4. So at 3 pi over 4, where are we at? At 3 pi over 4? What would it be? Negative 1. At 3 pi over 4, we're at negative 1 again. What would the next tick mark be? Well, the y value would be 0, but we'd be at pi. Okay. So at pi, we're back at 0. What comes next? 5 pi over 4? At 5 pi over 4, what's tangent? Just a positive 1 now. And then last, 3 pi over 2? Undefined again. Is this a continuous wave? No, it's got discontinuities, infinite discontinuities, right? But does it repeat itself? Yeah. This wave, the tangent wave, is just a series of things that go like that. Okay, so it just goes forever and ever, just like the sine wave repeats forever and ever, just keeps on going and blah, 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 right? Now, it is important to note that, like, I gave myself 4 tick marks, but in actuality, if I wanted to, I'm going to grab one of these. Okay. If I had graphed it on the same graph as a sine wave, you don't have to graph this, it's just me talking right quick. On a sine wave, we would have said this. Are y'all with me on that? And then tangent would have been like this. Because at pi over 2 I have my vertical asymptotes. So the 1 and the negative 1 would be right in the middle. So it's kind of up to you when you do your homework whether or not you want to give yourself a lot of space or a little bit of space. Kind of depends on the window that you're supposed to graph on. But this is what tangent would look like. You would have 2 waves in the time it takes to complete one sine wave. Okay? Where that last quarter is over here. Okay? All right. Let's talk period. What is the period of that wave? What does period mean? How long it takes to complete one wave? All right. How long does it take to complete one wave? It is pi. You go to the left pi over 2 and to the right pi over 2. So on either side of it, if you add that together, you get a length of pi. So the period is pi. Now, just as a reminder, guys, when we're finding, when we're writing equations or when we're graphing, we always use that formula 2 pi divided by b for sine and cosine. Is it going to be 2 pi divided by b anymore? No. Yeah, it's a horizontal stretch or compression of pi. So make a little note to yourself, pi or period would be pi divided by b, not 2 pi divided by b. All right, I need the domain. Where does this function not exist? I don't think it exists at the vertical asymptotes, right? So can y'all tell me where the vertical asymptotes occur? But aren't there infinitely many of them? Okay, so here's what I know. My domain is all real numbers except, what would you say, Rayon? Almost. This is pi over 2, but the next half pi would be pi, right? Pi over 2 plus 2 pi in? Is it 2 pi away from each other? There you go. Where n is a what? N is an integer. Okay, so let's talk about that real quick, guys. The first vertical asymptote, the first positive one, is a pi over 2. And then the next one is pi away, right? This one was negative pi away from it if I subtracted pi, right? Where would the next one be? Negative 2 pi away. And if I went to the right, it would be 2 pi away, right? So every multiple of pi, integer multiple of pi, after added or subtracted to pi over 2 is going to give me my vertical asymptotes. So can we go ahead and write down the equation for the vertical asymptotes? X equals what? Where n is an integer. Okay, range. All the way up and all the way down, right? So the range is all real numbers. Every y value is attained. X-intercepts. You and your neighbor talk about x-intercepts for a second. Where do you think they occur? So what are you going to write? X equals, yeah. What do y'all think? Pi n? Every pi that happens at 0 happens at pi, it's going to happen at 2 pi. Where n is an integer. I don't know why I keep drawing it like that. Okay. Y-intercept, what's the y-intercept? 0, 0. And do we have any extrema? Maxes and mins? Nope, we don't. Okay. So now I want us to write on the next graph, so the second graph on your notes page, I want you to write down negative 2 tangent of 2x, y equals negative 2 tangent of 2x. And, okay, normally when we start graphing a sine and a cosine wave, what's the first thing we graph? Usually it's the midline, right? Okay, do we have a midline here, or do we have a shift of the midline? Do we have a plus or minus something on the outside? No, so the midline is still the x-axis, true? Okay. Then we would draw our amplitude lines. We don't necessarily have an amplitude here because our wave is, like, it's already all the way up and all the way down, right? So what does this 2 out front do? Yeah, so these are the 2 points that you can stretch, okay? The fact that this goes up 1 now means it's going to go up how much? 2. But although, does it go up on that side? No, because what's that negative do? The x-axis, although in this case it wouldn't matter. Okay, I want everyone to draw a little x and a y out to the side, and I want you to draw a little dashed vertical asymptote on each side, and sketch a little negative tangent wave. So what does a negative tangent wave do? Start from above and then come down. So that's just a little reminder to myself that that's what my tangent wave is going to look like. Okay, so before I sketch the actual wave, I need to sketch, or I need to figure out the period, and I need to figure out my scale. So, how do we figure out the period? Period is pi over b. B is 2, so pi over 2 is the period. Do you guys want to take 2 tick marks, or do you want to span 2 or 4? Okay, let's do 4. So that means this is going to be one of my vertical asymptotes, and that's going to be my other one. What are the directions as far as sketching? What does it say? Sketch 2 periods. Okay, so here we go. All right. The midline is still at the x-axis, so the x-intercept always occurs halfway between my vertical asymptotes. I know that I need to start from above and go down. What's the only other thing that I need to do to sketch this? Right. When I go left and go up, I don't go up 1, I go up 2. And when I go right and I go down, I need to go down 2. And then connect them and do that. Now what we haven't done is label our x-axis. So can you tell me what x value this is right here? The period on this was pi, and so it went to the right half pi and to the left half pi. Exactly. If the period is pi over 2, that means you go to the right pi over 4 and you go to the left pi over 4. Okay? What would that make this first tick mark, guys? Pi over 8, and that would be negative pi over 8. I did say to sketch 2 periods of it. Okay, so right quick, I just want to have a little discussion with you. This right here is one wave. Yeah? Okay. Not that you can barely see it, but this right here is another wave. True? Another way to draw this, though, this right here is one wave. Okay? This right here is how much of a wave? And then what about that? So is that 2 periods? that is. 2 periods could look like this. 2 periods could look like that. Okay? Y'all with me on that? 2 periods could look like where you just start here. And so it could be bump, bump, vertical asymptote, and then dump. You know what I mean? So that could be 2 periods. Are you with me? On your homework, when you got your graph, if I don't give you enough tick marks to go, to give yourself 4 tick marks, you could either squish it and make it a thinner wave, like this right here, or you can split up the second period and make sure you do it on either side, okay? It's going to be up to you. Anyway, I need you to label the rest of this x-axis right quick. So do that. What's your counting tick mark? Well, every tick mark is 1/8. Every 2 tick marks is 1/4. So if every tick mark is 1/8, what's the third one? 3 pi over 8. What's the fourth one? Pi over 2, good. Remember, you could also count by 4, so if that's 1/4, then that's 2/4, or 1/2. So that means that last one is what? 3 pi over 4, 1/4, 2/4, 3/4. Yeah? But anyway, what's this, what's the fifth one? Over 8? Okay. I asked you to graph 2 periods of it, so I would expect to see another one. And then there we go. All right. Let's go ahead and sketch this out real quick, because we do have the time. How exciting. On the third graph, I want you to write down y equals cotangent of x. What is cotangent? Or cosine over sine, and in terms of the graph x, or the unit circle x over y. Alright guys, I'm going to still label this as pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. I want you to do the same. And I want you to plot those points. Okay, cotangent is x over y. So guys, can you tell me what cotangent of 0 is? Undefined. What does that mean? 1 divided by 0 is undefined, so we know we have a vertical asymptote. True? Okay. Talk to me about pi over 4. What's cotangent? At pi over 4, cotangent is 1. What about at pi over 2? What's cotangent? 0. What about at 3 pi over 4? What's cotangent? -1. And so then what do we assume is going to happen at pi? Okay. So tangent and cotangent are very similar, but what does cotangent do differently? It starts from above and goes down, but then tangents span on either side of the y-axis. What does cotangent do? It starts at the y-axis, right? So in my mind, whenever like I'm graphing things and I've got to remember, I just remember a tangent splits and goes up, cotangent starts and has its period and then goes down. And so that's basically what I remember. Okay? But anyway, if I asked you to graph another wave of it, where would you put it? On the other side. Good. That's good enough for this. What's the period? Pi again. So the period is pi. We don't need to go through all that, do we? Okay. So let's do one more graph and be done. So I'm going to write down 3 cotangent of x divided by 2 plus pi over 4 plus 1. Okay, where's my midline? You can draw your midline. You don't have to if you don't want to. Just remember that that's going to be where your new pretend x-intercepts are going to be. It's just the center of the waves. Okay, do I need to draw amplitude lines? No, because it's not a sine or cosine, right? It's a cotangent wave. What does cotangent generally look like? A vertical asymptote at 0 and its period. Yeah? And then it does this. So that's a cotangent wave. If you want to remember, you know how I drew this up here? You could just remember this is period cut in half, whereas this is just the period. You got a vertical asymptote at the period, 0 in the period, and then the tangent is plus and minus the period cut in half. So for this one, we need to figure out the period. What is the period? So pi over b. And what's b? 1/2. Good. So the period is 2 pi. So what are we going to do? We're going to go over 4 tick marks. Do you want to do 4 or you want to do 2? Let's do 2. Because it's well, it's okay. You can do, I'm going to do it with 2, but you can do it with 4. It doesn't matter because you got plenty of space, right? I'm just going to do it this way just in case you have to, guys. Remember, you've got a vertical asymptote of 0. Oh, crap. I know. Okay. Okay. Well, I'm still going to label this 2 pi. What I'm going to do is out to the side, I'm going to label this 0 and 2 pi. And then I'll think it out, okay? So I'll have this sketched, and then, so where is this x-intercept, guys? Pi? Yeah? Okay, so guys, here's my sketch in general. I would go up 3, I would go down 3. There we go. What's different about this one than the last one we did? Yeah, it's gotta shift horizontally. So how do I figure out phase shift? Negative c over b. So negative pi over 4 over 1/2, flip and multiply by what? 2. So where are we going? Hello? We're going to the left, pi over 2. Yeah? So how much is pi over 2? It's 1/4 of the period. I agree with that, yeah? So it's 1/2 a tick mark? Okay. So I'm going to use this to plot this over here. Normally my vertical asymptote would be at 0. Now it's going to be 1/2 a tick mark over at what? Negative 1/2 pi. Can you tell me where my second vertical asymptote is going to be? What's half pi over from 2 pi? Yeah, 3 pi over 2. So the other vertical asymptote is at 3 pi over 2. It probably would be easier to use one tick mark on this, but I will. Okay. Where is my new x-intercept? Well, not x-intercept, but midline point. 1/2 pi? Good. It was at pi, now it's going to move to the left half pi, so it's going to be at 1/2 pi, which makes sense, it's halfway between the two, true? And then, okay, I need to go left and up or left and down? Left and up, how much? 1, 2, 3. Right, 1, 2, 3. And there we go. Oh, crap. That was kind of hard to draw.
Yeah, especially if you want to make this
Really thin? Now, I did say to sketch two. Now, okay, I'm going to pretend for a second. If I had made this, crap, why did I do that? You know what? I'll just box the whole thing. Jordan Joycelyn. And then I'm going to pretend. You're rude. Okay. If I made that my y-axis, then I could have said over, well, I don't have enough space. Never mind. Hey, I need, can someone grab, y'all need to grab a homework, but can you hand it to me so I can explain? No, 4.6, yeah. Guys, I just want one because I need to explain something. All right, guys. Hey, I need everyone looking at the video while you're grabbing one. Can I graph number 1? Can you graph number 1? No. Yes. Can you graph number 2?
Yes.
No. Can you graph number
Yes.
3? Yes. Can you graph number 4?
No, yes.
No, you cannot. Can you graph number 5? No, not right now because I haven't talked to you about it. Can you graph number 6? Only if you make this change. Are you listening to me? Guys, I need you to listen. Are you listening to me? That needs to be a pi. Okay? Okay, so far you can graph 1, 2, and 6, yeah? Now, everyone look at number 7. Okay, hey, I need everyone looking. Can you work number 7? Yes, it's a sine. Can you work number 8? Yes, it's a cosine. Can you work number 9? What do you got to remember for the formula for period?
Pi over 2.
Pi over b, not 2 pi over b, right? The same goes for number 11. It's cotangent. Also what? Pi over b. Number 10, guys, it's secant, but just so you can go ahead and work on it, it's still going to be 2 pi over b, just like for sine and cosine, okay? Are y'all with me on that? Okay. So I would expect you to be able to work. No, not 2. 1, 3, 6, and 7 through 11 if you wanted to. Oh my gosh, that was